Hi everyone, this is John Wen. Today is November 4th, 2021. In today's video, I'm going to still report my progress since the past week. As you can see, I mainly work on the journal version paper. The progress is about 10% in the past week. For the past week, I put much efforts in the implementation of the executor because we want to reuse any trained model on new dataset as well in a regular workflow. So this is a goal. And in the past week, I mainly work on the backend CUDA side because we need something that is able to accept some specification that is include the trained model, for example, like the architecture, the saved weights and bias, and reconstruct the new network on the new dataset. So that will carry out the testing directly without any training. So that's something I was working on from the past week. So if we take a look at the Visual Studios, here is a CUDA code. We are going to have, for example, like to reload the weights and bias, and we have to do some parsing before that, because it's a little bit tricky. The escape of the Java and the C++ is a little bit different, so we have to do some work after we receive the information from the JNI. So here is one of example that we want to receive. So we just hard code it here. This is something we want to receive. Here is the input dataset and the layer architecture, and saved model include the weight and bias for every layer. So right now we are able to successfully run. So that means we are able to reload the module and model, and let me close this one and run it again. So we are able to reload the model and testing on the new dataset directly and calculate the accuracy. So as you can see, it's 86%. So the original, which is come from the training. I think the testing result is about 82% because we have seen the data set before, so it makes sense the final testing on overall data set is higher than the previous testing outcome. So this is something I was working on, and also I have prepared the GenAI parts as well. So this is the GenAI parts, which is going to be compiled into a DLL file. So I add some GenAI parts in the similar code. For example, like we have the GenAI call that is going to receive the specification from the Java side and do the reconstruction and do the direct testing. So I also compile this into an executor.dll. So that means this is ready for using for the Java side, and currently I'm working on the Java side. So in the Java side, I hope to be like this. So here is one of example, like a workflow. We have the two input files. One is a saved model that had been saved in a JSON file, and also a new data set. And we can reuse any executor as a task. So this is a regular task, not an task. So this can make sure that we can reuse this executor in a big part of the big workflow in the future. So we can execute this by, for example, like local executor, executor beta, etc. So we can incorporate this as a part of the regular workflow in the future, and this will output a TXT. So the construction is also similar to the trainer because we're gonna have a new package that is called an executor, and we have the base class which is an workflow executor, and we have, for example, like local GPU, so which is quite similar to the trainer, but we have slightly different because this one we don't need to dynamically construct the layers. But this one will just read and parse the JSON file and prepare the specification. So we can take a look at the Java side. So as I said, it's an ongoing work. I haven't wrapped up everything, but Currently you can still see some codes over here. So the executor package will include the base class, which is an executor and workflow executor, and this one will be responsible to has a JSON file parsing method, which is going to parse the JSON file into the specific information to prepare the specification that will be output to the CUDA side. And also in the local GPU executor, we are going to call similarly, we are going to call the GPU resource management. So this GPU resource management package will be reused again by the executor, not only by an trainer. So right now we have two parts will use the GPU resource management. One is an trainer, the other one is an executor. The difference is we are going to input a different DLL into the GPU resource management. So that's something we have to modify that as well, because before we don't allow the inputs, but I think this is a good design. If we can have this one as an input, and later we can have more more DLLs to be involved in the GPU resource management. So yeah, so I think that's about this package and executor. And later we can have a task. I think I have a task already, but I haven't run it yet. So the task is called an executor. So this is an example of an executor. We're going to have two inputs. One is a JSON file, one is the input data set. We're going to construct this as a regular workflow later, but in the run method, we're going to call the workflow executor local GPU, and the result will be write into a regular file or output into the subsequent tasks in the future. So yeah, I think that's pretty much about the updates from the past week. I will keep working on this one, and hopefully after this one I work on the web version as well, so we're able to construct a regular workflow and in the web bench, and we can execute that in the local executor. So thank you so much for your time, and hope you enjoy this video. Until next time, happy coding.